Hello, science students. Welcome to today's lesson about forces that are able to act at a distance. Each of these forces is able to affect the motion of another object without coming into physical contact with that object. We're going to learn about the magnetic force, electric force, and gravitational force. Let's start with gravity because everyone experiences gravity at all times during their life. But let's think about a specific instance related to gravity. Think about the last time that you jumped. As you applied a force with your foot to the ground also applied a force to you. That force on the ground caused your motion to change. You accelerated upwards. As you moved further and further upwards and further away from the ground, you started to slow down. The reason for this is that your applied force only occurred for a very short period of time while your foot was still in contact with the ground. As soon as you were elevated, that force pushing you upwards is no longer acting on your body. But gravity has been acting on you the entire time, and gravity is beginning to slow you down. Eventually, you'll reach the highest point of your arc and you'll begin to fall back to the ground. Gravity is that reason that you fell to the ground. It's a force that pulls you towards the center of the earth. And gravity exists not only between you and the earth, but between all matter. Anything with a mass has a gravitational field and is affected by the gravitational fields of other objects. Gravity pulls you back down to the ground. A good definition for gravity is the universal force of attraction acting between all matter. All matter wants to be grouped together. It wants to attract other matter to it. Gravity causes you to fall. When you slip, your center of mass is no longer over your legs, which were supporting the rest of your body, and that mass gets pulled back down towards the ground. Gravity can exist between all objects with mass. That includes things like the Earth and the Moon, and also has effects out in space. You may have heard the term that you're weightless in space because there's no gravity. Gravity exists, but where you're at in space is so small on your mass compared to the masses of other objects, like the moon and Earth. Earth is pulling on the moon. The moon is pulling back on the Earth. Remember Newton's equal and opposite, Newton's third law? Action, reaction. The Earth is pulling the moon in. The moon was moving along and entered Earth's gravitational field and starts to get pulled towards the center. This curves the moon's path and causes it to orbit on the Earth. But remember, the moon is pulling on the Earth as well. And that phenomenon is actually what causes the tides. The moon is pulling on the Earth as it rotates around it. This causes the water in the ocean to bulge slightly towards the moon. This causes what we would consider a high tide. You can see that there's a high tide directly in line on the near side of the moon, as well as on the far side of the moon. The areas that are perpendicular to the location of the moon end up with a low tide because some of their water has been pulled towards the moon. Gravity is a force that's a little bit easier to understand because it acts on such large objects. For instance, the sun has a gravitational field that pulls on all of the planets in our solar system and causes them to rotate around the sun. Gravity affects you on Earth, so it's an easy object to think about on the large scale. But there are some forces that act at a distance on a small scale. So let's shift from really big, like the galaxy, to down small, like an atom. When you think back about the structure of the atom, you probably remember that there were three major parts of the atom: the proton, electron, and neutron. We've since learned that there are many other smaller parts that make up these major parts, but for what we're doing, proton, electron, and neutron are enough. If you recall, they have an electrical charge. The proton has a positive charge, the electron has a negative charge, and the neutron has no charge. The electrical charge on the particles can either cause them to attract each other, pull each other towards them, or repel each other, push them apart. And like charges repel one another, opposite charges will attract each other. When you take a look at this diagram, you can see that the positive and negative charge both end up pulling in towards each other and will move closer to each other. Both of the positive charges, when there's a positive and a positive, they push against each other and they're going to repel each other. Same thing with two negative charges. They're going to repel each other as well. So we can think of the electrical force as the attractive or repulsive force that acts on two charged bodies. So over here on the side, you can see we've added in another key vocabulary term here: electric force attracts or repels charged bodies. Here in our picture, we've got a person who is interacting with an electrical charge and electrical force. As that person is putting their hand on that electrically charged device, that electrical charge travels through them and out through their hair. Since all of the hair has the same electrical charge, it pushes off of the other hair strands and ends up standing up in this wonderful, beautiful, crazy scientist Einstein look. As those electrical charges line up, you can start to end up with a magnet. Electrical charges are individual. Something has a negative charge. Something has a positive charge. The magnets have both a positive and a negative charge in what we call different poles. And in a magnetized object, those electrical charges have all lined up and are flowing. They're able to move, and they cause what we call two different poles. That magnetic force is created between moving electrically charged particles. That force that extends between moving charged particles. That movement creates what we call poles, and magnets have two, so we call it dipolar. One is the north, abbreviated with an N, and one is considered the south, abbreviated with an S. We use these terms because we notice that the Earth has a magnetic field that is at the north pole of our Earth and at the south pole of the Earth. And just like those electrical charges, like poles repel each other and opposite poles attract each other. All of these forces that are able to act at a distance do so because they create what we call a force field. If you think about that term field, like a sports field, it's the location where that particular sport would be taking place. A force field is that area or location where that object's force is present. Gravitational fields are a force field, electrical fields are a force field, and magnetic fields are a force field. All of these fields are able to apply a force to objects without actually touching them. While it's difficult to see a gravitational field firsthand or an electrical field firsthand, and we don't see the field around a magnet as we pick it up and hold it, we can observe these fields as we look at how different objects and matter interact with them. In our example here, you can see a bar magnet with a north end and a south end. Remember, these have that flow of charge. So that north pole is emitting a charge. That charge is curving back around to the south pole. And you can see exactly how that charge, that force, has caused the iron filings, which are magnetic, to bend and curve within that force field. You can also see that force field affecting the compass. Compasses have a magnetic arrow that points towards a gravitational field. This magnet is pointing towards the north part of the magnetic field. Here, that same one is pointing kind of down along that curve towards that north magnetic field. This one in the middle is kind of pointing both ways because at this point that gravitational field is magnetic field is curved and kind of flat here before it enters back into the south. Here, that north arrow is pointing up this direction because it's pointing towards that curve of the north magnetic field. Same thing here, north is pointing upwards, and so you can see this arrow points up and in, points to the side, points down and in, points down. All of them are pointing along that line of that magnetic field. The important things to remember are that gravity, electrical forces, magnetic forces create force fields around themselves where they can affect different objects without physically touching them like we saw with applied forces. Thank you for your attention to today's lesson. I hope it helps you better understand forces that act at a distance.